Okay, for activity 1.2.5, you want to start a new circuit in Multisim Live. And on the top, you're going to click on Untitled Circuit, and we're going to rename it 1.2.5. 555 timer. You're going to go to the waffle icon in the top left, and you're going to press Save. Make sure you make your circuit public. Press OK. For this circuit, we do not need to change the sheet size, so we can just get started. We're going to start by going to Analog on the left-hand side, and you're going to click on Timers. Then you're going to select the first option, LM555CN. Place that in the middle somewhere. And then I'm going to start at the top. So I'm going to grab under Sources, DC Voltage. I'm going to place that on the top left. And then I'm going to go to Schematic Connectors Ground to ground it. Connect that. And then we're going to connect the voltage source to VCC. Verify that it is 5 volts. If not, you would double click. On the right-hand side, you can change the voltage where it says DC mag. Next, I'm going to go to passive and click resistor. Replace the resistor, and then I'm going to rotate it. Double click on it, and then on the right-hand side, we're going to change the resistance to 330 ohms. Enter. I'm going to change the name of this so it's consistent with the lab. Instead of R1, I'm going to make it RA. I'm going to copy. So I'm going to click on it and click copy. And I'm going to paste a second one below it. And we're going to call this one RB. Then I'm going to go to passive and select capacitor. I'm going to place it right here and rotate it. And I'm going to copy it and paste another one so that it's in line with the resistors. And you want to verify, be consistent with the lab. We want C2 to be on the left and C1 to be on the right, just so the naming is consistent with the activity. I'm going to click on C1, and C1, I'm going to go to capacitance. And instead of 1, I'm going to click 0.01, and you want to keep the micro. So it should be 0.01 microfarads. And then C2, we're going to change to 22 microfarads. Sure you keep that micro. I'm going to go to the ground on the top and copy it, place another one on the bottom of the circuit. And then the last thing is I'm going to connect all of these. So RA, I'm going to connect to the wire up here. And then I'm going to go to RST, connect it with that wire. Then I'm going to connect RA to RB. And then connect DIS to that wire. Then I'm going to connect RB to C2. And then THR, we're going to click. We can make a corner, and then you want to connect it halfway between RB and C2. And then TRI is there. Next, you want to connect CON to C1. And then we're going to take C2, connect it to ground, and then connect ground to that wire, and then connect C1 parallel. Last thing we want to do is we want to click on Analysis and Annotation and go to Voltage Probe. I'm going to place it in the top right. And again, you need to click the keyboard letter J to make a junction. J is in Jaguar, and connect that to our output. I'm going to go ahead and save the work. And then before continuing, just confirm that your RA and RB are both 330 ohms. Your C2 is 22 microfarads, and your C1 is 0.01 microfarads. I'm going to press Run Simulation. And what's going to happen is you're going to see the voltage probe go between 0 and 5. So it's just turning on or off. Remember, when the capacitor is charging, it's going to output a 1. When it's discharging, it's going to output a 0. 5 volts is going to be charging, 0 volts discharging. So I'm going to switch to grapher mode. And while it's running, I'm going to look on the right-hand side, scroll down to time divisions, and I'm going to click twice to 5 milliseconds per division so I can see the waves. If you can't see the top of the waves, you can change the maximum to 5.5 volts. And then we're going to press stop. I'm going to click on cursors, x-axis. And I'm going to drag the first cursor to the rising edge of one wave, and the second cursor to the rising edge of the next wave. Try to line it up as perfectly as you can. It's not going to be exact, but I look down and delta x right here is my period. So in this case, the period is 15.054 milliseconds. I'm going to write that in the text box on question 2. And then the frequency is 66.426 hertz. I'm going to write that for F equals 66.426 hertz. Your numbers should be slightly different because if I don't move the cursor perfectly, you can see it changes to 66.187. So everybody should be a little different. The last thing you have to do is you have to find the duty cycle. So in order to find the duty cycle, I take cursor 2 and I'm going to drag it to the falling edge of the first wave. And then I'm going to look down at delta x, and it tells me that time high, so the period, the time spent in 5 volts is 10 milliseconds. So I'm going to use the equation, time high divided by the period, capital T, times 100% to calculate my duty cycle. Make sure that you put your units on question 2 for full credit. And that is it.